We don't need expensive LED volumes to create virtual productions in Unity from our desk. Every time I start a thing, something likes to break. Eve, I've busted some light bulbs on the chandelier again. Thank you, lady. Thank you. Thank you. Woo! Saved. I love it. All right. Where was I? Oh, that's right. I was talking about being able to make virtual productions at our desk. Great for a lot of scenarios. Put your imagination to it. How can I prove that I'm not using LED screens or anything like that? Well, really easy. I can show you right here. We can see I'm surrounded by green, but this is no zoom background and this is no flat image. Let me show you around there. But before we dive in, notice that here on my desk, all that we have are a few coasters. I have my mug, my mouse, my laptop, and a desk mat. That is it. And in my scene, I have interactive lights. Notice that as the light comes on and off, it affects me and integrates me into the scene, into the environment, as if the light were truly here and affecting me. How great is that? And to really sell the effect, all I've got on my desk is a piece of blue tape, which I can just kind of use as a marker to tap on, tap off for that interactive experience. Of course, it wouldn't be filmmaking or virtual production of any kind if we couldn't set our scene back to 1. So with a designated keystroke, I can set our scene back to the original state and then start it up all again. So I can just bring on the light, turn off the light, or at the beginning of our scene, I can bring the desk lamp on and bring the scene to full brightness so that when the bulbs blow, the effect is felt. So I'll demonstrate that one more time. As I pantomime the lamp action and press my designated key, I'll break everything down momentarily. So start up the scene and start speaking and move along. And then sooner or later, bam, bulb breaks. Well, that's just frustrating. And of course, that provides the performance opportunity to show a little frustration and call in the hero of this production, Miss Eve, as she does her magic, fixes the light bulbs. Hey, thanks again. She's always on cue. I love it. It's fantastic. So how is all of this coming together? How is all of this done? Let's dive in. Let's truly look at everything. Starting in our scene view, we can see that this is a 3D environment. This is not a 2D background. We've got actual 3D geometry here. I've got a staircase. I've got library panels and just a basic floor along with a desk. Here's the desk, and on this desk we have a plane. This plane is projecting my webcam footage. Now, you can utilize any production camera that you might like to use. I happen to be utilizing my own iPhone through continuity camera as my webcam of choice. It works flawlessly, it's wireless, and I can move it about, and it's incredibly useful because I can also utilize my iPhone for moving tracking shots in which the environment moves along with the camera. It's like having a camera and motion tracking all in one platform. But that's another video for another day. And yes, I'll be doing a video on that right here on this channel. So like and subscribe if you want to stay up to date and see that coming down the pipeline. Now let's focus on what we're doing here, right now. Let me show you how it's all done. In my hierarchy, within my world, I have all of my game objects. I have all of my timelines. I have my world geometry, set dressing, my foreground elements, and I have a chandelier. So the chandelier and the desk lamp, these are just geometrical pieces which I have added point and spotlights to. we can see that within the chandelier, I have two groups of bulbs. I have working bulbs and broken bulbs. The broken bulbs, if I turn them off in the inspector, we can see that that is the look of our chandelier after the bulbs have broken. There they are on, and then of course our working bulbs are simply the two bulbs that never go out. They always stay on. In the foreground elements, I have my desk and I have my webcam streaming rig. This webcam rig brings in the live footage, the live feed as I perform and as I interact with you, the audience, in real time right here, right now. And here, of course, is the lamp. And within this lamp, I have a point light. And as a child of this point light, I have several other lights which illuminate spaces such as, well, let's see, we'll break it down. Let me turn off a few things so we can see more clearly what's going on. So here in scene view, we can see that if I turn off go back to game view, if I turn off the point light, the foreground elements, myself included, are in complete silhouette. I utilize a timeline action to turn this point light on. And with this point light are also additional lights. So we have a spotlight, we have a couple of area lights. The area lights just cast a little more light onto me. I use two so that I can get a gradation effect, and that's really all that's happening there. All of the magic happens using Unity timelines. I have an empty game object that is a parent to many individual timeline game objects. An empty game object is, think of it as a folder. It's a means of organizing your scene so that you can collapse and have everything together under one label. I have a timeline for Eve. If I pull up my timeline window, I have hand animated keyframes for moving Eve through space. We can see that we can see her move as I scrub forwards and back on the timeline. Below this, I have animations, character personality animations, to give Eve a little bit of life by animating her right and left arms. And I do this separately just for the ease. The first thing I do when animating a character is I simply block her through the space. Here's your first mark. Here's your second mark, tilting up. Then I want you to kind of twirl up and examine the chandelier before rotating around the chandelier. All of these are individual keyframes which just move her through space. It's blocking, scene blocking for theater and film. If you're familiar with the concepts, this is no different. This will be extraordinarily familiar to you. I then animate the personality of the arms tilting forward and back separately on their own tracks. That allows me to just keep things really neat, really organized, super easy to observe, and makes things much, much easier to work with. I also have a timeline for turning all of the lights in the scene on, as well as all of the lights off, and then as a reset, which is simply a means of resetting our scene back to 1. To borrow parlance from film production, we have a timeline which does nothing but turns on the point light and all of its children lights. It turns them on, and we have another that turns the light on, and after a period of time, it burns out our bulbs and our scene goes dark. And then we have desk lamp off. So I create the timelines, and then how do I control the timelines? Well, if I go into my timelines empty game object, we can see that I've added a custom script which accomplishes the following. It plays a specified timeline on a key press. I simply assign the timeline I wish to control by dragging the timeline game object over into this field, and then assigning which key I would like to press on my keyboard to trigger that timeline. And it's a and its corresponding action. Now, what's really neat about this, it's not necessary to use keyboard keys. One could get a foot pedal controller, a USB foot pedal controller, to sit right below your real-world desk, and with a tap of a foot, you could trigger a co-host, an environmental action, weather changes, lighting changes, soundscape changes, all manner of interactive, real-time produced elements, simply by tapping a foot pedal off screen. The way I'm doing this, I'll reset everything back to 1 with the minus key. And this happens, the game view must always be active. When I hit the minus key on my keyboard, the scene goes dark. Let me reset Eve back to her original spot. There we go. So now our scene is back to 1. So if I hit on my keyboard, if I press the comma key and I pantomime tapping on my desk where I have my blue marker, my light comes on. Let's look at that timeline. So we'll find timeline desk lamp on. As I zoom in, we can see that I have added the point light, which is located here in this virtual lamp, as an activation track. I do so simply by finding the point light one wishes to add, dragging it through a timeline, and choosing activation track. Then here on the actual track, I choose 1 frame. The reason I do this is so that the timeline itself starts and ends immediately. It's simply a 1 frame action because it's just a light bulb going on, going off. In this case, it's going on. I hit the comma key and this timeline begins. The clip turns the lamp on. And then if we look at the post playback state, which we can do simply by clicking in an empty position on an activation track, we can choose to have the post playback action be that it remains active, or the game object becomes inactive, it reverts to its previous state, or we leave as is. Well, because I'm turning the light on, I want this game object, the point light, to stay active. And so that's the state I choose. Now, if I reset everything back to 1 with my minus key, well, what is this doing? Let's scroll and find our timeline reset timeline right here. We can see I have a lot of activation tracks. For my working bulbs, I'm telling them to all come back on and to stay on in their post playback state. I'm telling all of my broken bulbs to turn back on and to stay active. I'm telling my sun, I'm telling to turn off, and my moon, I'm telling to turn on. And then I've got other lights in my scene that I am resetting to their original states. Let's bring all the lights back on. I have that assigned to my / key. I do my pantomime action, everything comes on, and then my bulbs blow. Let's look at that timeline. Here they go. All right. So I have my timeline desk lamp on flash. Here's the desk lamp, turns on. The broken bulbs turn on. But then at the very end of the timeline, their post-playback state action is inactive, meaning they burn out. I then have a flash bulb effect. This is simply an activation track that is 2 frames at the end of the timeline, which activate a very bright light in the back, and then immediately revert them to inactive once again. And it happens so quickly that it just looks like a bulb flashing at the end of its life, burning brightly and then out forever. Of course, this timeline also turns on the sun in the room, which is the ambient light. And then I have another special It's just a special effect light here, which is doing the same thing as our flash bulb. When I call Eve, we saw that in our timeline there was a lot going on. I've got her animation around the chandelier. I have an activation of a spotlight that I've made positioned within Eve to be her maintenance beam. So it turns on, and then after it reaches its end, and we see that the broken bulbs become active and her beam deactivates once she's fixed the lights. So we can see that in action here. She floats around, she activates her beam, and then the lights come back and she shuts her beam off, having succeeded in her mission. I've also given Eve 2 sets of eyes, her normal state blue eyes, and also a second set of green eyes, which she will flash at me to let me know that, hey, mission accomplished. We can see that flash here, flash green, just for a few frames, and then back to blue before she floats off to go about her day, whatever she may be doing. I don't like to micromanage, so I let her do her thing. Here we have activation tracks and deactivation tracks for additional lights throughout the scene. The audio comes into things through my podcasting microphone, and this is what everything looks like, I guess, broken down. This is how the sausage is made, so to speak. When one is ready to produce and actually output this, to stream it to YouTube, if you want to record it with OBS, the way I go about this is through Unity's build settings. So I simply select the platform that I happen to be running on. I'm on Apple Silicon. It's very important that in the player settings, you can set your resolution parameters. If you have a machine that will handle 1080 without chugging while simultaneously streaming or simultaneously recording OBS clips to disk, then you can make the default screen width and height to be the resolution of 1920 by 1080. If you think you can do half of that, you can of course do the 1280 by 720. There are other parameters here, of course. Camera usage and microphone usage descriptions under the player settings are very important. You will not be able to export and build your Unity project to a successful external file if the camera usage and microphone usage fields are empty. Just pop in a little description of this is why these permissions are required, and that'll take care of it. You just cannot have these fields blank. Otherwise, you will get an error when you choose to build and run. Then once those two fields are taken care of, you can just tap this build to run, and it will ask where you'd like to save to, and then you can just hit save and be about your business. Then it's just a matter of opening that game file, and it will look exactly as things look now on this screen, minus the interface. What you will see instead will simply be the game view at the resolution you exported your file to. It might be full screen, it might be windowed. That comes down to whether you set it up as full screen or windowed within the build settings, which we can, if we pop back in, we can see that those options are right here in the player settings. We can choose under resolution and presentation to export as a full screen application, a maximized window, or windowed. And if you'd like to be able to resize, then of course you can just tick resizable window or non-resizable. I think it's best to choose the resolution that your machine will handle extraordinarily well, and then leave resizable unchecked. That way, every time you open that file, it will be the correct dimension and resolution to give you a very smooth playback without any kind of jittery playback or chug. What happens if you can't export and play a full 1080p video? What do you do in that scenario? Well, I like to use Topaz Video AI Upscaler. I simply grab my original file that is sub HD, and then I slide the enhancement filters and give myself a preview. Might try a few iterations, see what looks good, see what looks clean. I first export the original resolution with all of the enhancements, and then I refeed that enhanced original file back in and upscale it. So I might upscale to 720, and then I'll upscale the 720 to 1080, and then that 1080 to 4K. And then that usually looks pretty good. In fact, I'll be doing that to a few videos as soon as I finish recording this video for all of you. Did you like this? Did you think this was interesting? This, I think, unlocks a lot of really cool potential when it comes to podcasting, when it comes to demonstrations, when it comes to literary channels of like telling stories and reading passages from books and setting a tone, setting a mood. There's so many opportunities, even for more commerce-related situations, where maybe you want to have an interviewer and a guest in a specific branded environment. You can go really high-tech, really interactive. You can do a lot with very little, as I am demonstrating right here now. It's just a couple of pieces of green, which we can see here. I'll make a video about the specific green screen I'm using, not because green screens are special, but because I really like this setup. It's on a collapsible frame, and it's super large, 13 feet wide, 8 feet tall, and it packs up so small into a bag that's 3 feet long, and it's lightweight, and yet no stands are needed because it stands on its own frame. It's brilliant. I cannot rave about it enough, and I'll share this with you in an upcoming video. This is green felt, I believe from Joann Fabric. Nothing special about it. And of course, the machine that I'm running on is this is not a beast of a machine. This is a powerful machine, but this is not a gaming PC. This is an Apple M1 MacBook Air. MacBook Air with 8 gig of memory. That's the base model. And look what we're accomplishing. Look what we're doing. This is fantastic. This is incredible. And the iPhone, I cannot rave enough. Mine is an iPhone 13 Pro. I use it for motion tracking, moving videos with the Jet Set app. I use the Lightcraft Jet Set app for moving virtual production shots. That workflow is coming up for you in a future video. This is just a webcam feed straight into Unity. And I'll be doing a video strictly on the webcam feed itself coming up as well. However, I can give you a quick rundown of how this is structured. In the webcam streaming rig, this is an empty game object, strictly for organizational purposes. Everything below it, as a child, contains the functionality of our web streaming. We have a scene main camera, which is a brain for a Cinemachine camera setup. And here is our Cinemachine virtual camera. And this virtual camera is controlling our focal length as well as our physical camera properties such as aperture and depth of field, which we can see is happening here. We have our main performance screen. That is the display screen upon which you see me. And powering this screen is the webcam system itself. We have a webcam streaming game object to which I have attached a list webcam devices script, which displays in our console all of the cameras that are currently attached to this machine. Here we can see a webcam device with the name of Primary's iPhone camera. I simply copy this and we save this for later because it comes in handy here on the webcam stream itself. I plug in the name that I copied from console into the requested device name field. I list the resolution for which I desire my webcam stream to display, and of course I designate a requested frames per second. Now, how do we get this webcam stream onto the performance screen? Well, that happens through a webcam render game object, which marries the two together. Here we can see a field for a webcam stream. I simply drag the webcam stream into this field and then designate a render texture. This render texture is the same render texture in our project that is utilized by the material of our performance screen. We can see here it is, the render texture. So if I simply ping this render texture in our project, we can see we are utilizing a webcam render texture. And if I go into the webcam render game object and I ping the render texture being utilized, it's the same render texture. This script marries the webcam stream to the performance screen output in our scene. Like I said, I'll get into more of this in detail on a future video. Please like and subscribe. If you want to follow this, if you want to learn more about doing virtual production in Unity, like and subscribe. It helps me out tremendously. The sets are fake, but the coffee is real. Watch another video on virtual production with Unity. Subscribe to this channel or support me on my personal Patreon. You can even get your own personal Patreon, and why not? It's Patreon without the fees. You create your content. Shouldn't you keep more of the revenue in your own pocket? I think so. Learn more about all of that right here. You can support me or learn to support yourself. But if you can only do one, do the latter. Take care of yourself.